Let's build out our Caesar cipher algorithm. First, we will define our algorithm as a function by saying function Caesar cipher takes in two parameters, a string and a number. The first thing that we want to do inside of our function is we want to make our entire string into lowercase. So we will say variable lowercase string equals string dot to lowercase. We then want an alphabet array filled up with every letter in the alphabet to reference when we are shifting each of the letters in our string. So just like in our isPalindrome algorithm, we will create an alphabet array by saying variable alphabet equals the string A, B, C, D, all the way up to Z, dot split. We now have an array filled with every letter of the alphabet in the correct order. Great. We are now going to loop through every letter in our string and shift it the correct number of places in the alphabet. For right now, we are going to use our lowercase string for all of the functionality. If one of the letters in our original string was uppercase, we want it to be uppercase in our new string too, but we will deal with that later in our algorithm. So we will loop through every character in our string by saying for variable I equals 0, while I is less than lowercase string dot length, we want to increase I by 1 on every iteration, so I++. On every iteration of this loop, we want to add our newly shifted letter to a new string, so we will define our new string up here by saying variable new string equals an empty string to start with. Now, in our for loop, the first thing that we want to do is define the current letter. So we will say variable current letter equals lowercase string at position I. Good. Now let's get the easy stuff out of the way. Like, what if the current letter is actually a space character? Well, if it is a space character, we simply want to add that space to the string without changing it at all. So we will say if current letter equals a space, then we want to add it to the string by saying new string plus equals the current letter. Then below that, we want to write continue, which will simply move our for loop onto the next iteration without doing any more of the functionality that we are about to write in the for loop. So it basically just says skip whatever functionality is left in this code block and move onto the next iteration of the for loop. Great. So we have our space characters taken care of. The next thing that we want to do is determine where our current letter is in our alphabet array. So we will say variable current index equals alphabet dot index of our current letter. We have now located the index of where our current letter is in our alphabet array. We now want to shift our current letter by the number passed into our algorithm to get our new letter. We will do this by first determining the new index of our letter after it has been shifted. So we will say variable new index equals current index plus num. and this is the index of our new letter in our alphabet array. So all we have to do is get the letter that is at this index in our alphabet array and add it to our new string. But there is something we have to consider first. What if our new index is greater than 25, which is the last index of our alphabet array? For example, what if our current letter is Z, which is at index 25, and we are shifting every letter by the value 5? Well, then our new index would be the number 30, and there is nothing at index 30 in our alphabet array because it ends at index 25. So to deal with this situation, we will say if our new index is greater than 25, our new index will equal new index minus 26, which is the length of our alphabet array. This line is essentially just looping our letter back around to the beginning of the alphabet if it goes off the end. We also want to do this if our new index is less than 0, which could happen if we pass in a negative number into our algorithm to shift every letter backwards. So we will say, if our new index is less than 0, then our new index will equal 26 plus our new index, which essentially wraps the letter back around to the end of the alphabet. And then finally, we want to say new string plus equal to the alphabet at our new index, which is our newly shifted letter. Great. We now have every letter in our string being shifted correctly and added to our new string correctly. That is the main functionality of our Caesar Cipher algorithm. All we have to do now is deal with a few edge cases. What if one or more of our letters in our original string is uppercase? Well, then we want that newly shifted letter to be uppercase in our new string as well. We will do this by adding a new line right here and saying if string, which is our original string passed in, at position I equals string at position I to uppercase, then we want to do something in here. And just to clarify, string at position I is the same letter as our current letter variable up here. The only difference being that string at position I could possibly be an uppercase letter. So if this is an uppercase letter, then we simply want to do new string plus equals alphabet at new index to uppercase. If it is not an uppercase letter, then we want to do this line. So we will put an else right here. Great. And the final edge case that we want to deal with is, what if we pass a number into our algorithm that is greater than 26 or less than negative 26, like 300, for example? This is very similar to what we dealt with before up here, in the case that our new index, after shifting it, was either greater than 25 or less than 0. So if we initially pass in a number that is greater than 26 or less than negative 26, like 300, we basically want to simply keep looping through the alphabet until we have shifted the letter forward 300 times. A simple way to achieve this functionality without actually looping through the alphabet a bunch of times is to use the modulus operator that we learned about in our FizzBuzz algorithm. So up here, we will write our original number, num, equals num modulus 26, which is the length of the alphabet. Since the result of this operation can only be between the numbers 0 and 25, or negative 25 and 0, if the original number is negative, this will turn our number, num, into an appropriate value. For example, if the number negative 27 is passed in, negative 27 modulus 26 will return to us the value of negative 1. Shifting a letter by negative 1 places, or by negative 27 places, will give us the same result, but it won't give us any errors. That is why we do this operation here. Great. The final thing that we have to do inside of our algorithm, down here at the end, is return our new string. And that is it. We have created our Caesar Cipher algorithm. Let's test it to make sure that it works correctly in the next lecture.